Today I'm going to deliver like discussion or speech about 5G core, and then I will I will I will mention most of the things that I have learned about this. So okay, so let's start it. Let us first start from RAN. Here I have the spelling is wrong. It is RAN. RAN. RAN means radio access network, and G means new generation. So this UE can consist of any devices like our watch, car, and all. So let's talk about RAN. So this is the like this separates the traditional base station function into two components. Previously, we used to have base station in like 4G or 3G GPRS during that time, but in 5G it has been separated to two components. One is GNB, which is also known as G Node B, which handles like the radio signal transmission and receive reception and the base processing. And then it has one central unit also, which performs central tasks like scheduling, resource allocation, and then connection management also. It has been done by RAN. Now, RAN actually, as compared to like in 5G system, it is GNB. Previously in 4G, we used to have ENB. So instead of ENB, it has a few like efficiency, like it has higher frequency. Like we can also say it has waves for ultra fast data speed, which is provided by GNB, and then massive MIMO, which is also known as multiple input and then multiple outputs, which employs like various antenna at both GNB and UE to improve capacity, coverage, and beamforming. So this is how like GNB is like an enhanced version of eNodeB. And we can see that UE is like 5G NR modem. So what is this UE? In 5G system, our 5G, our mobile or UE need to have that 5G capability so that only it can communicate as a 5G network. Now, how our devices will have that 5G capability? So, like it has that 5G NR modems. It's a kind of chipset which has been installed by chip manufacturers in our mobile or in our car or in our connected devices. And then, like suppose smartphones and then tablet, which are equipped with the new 5G new radio NR modems to support the high frequency and advanced feature of 5G RAN. So nowadays, mobile manufacturer keep their chip in such a way that it will support the 5G architecture and then it will connect to the GNB. Now, what is the core network? Let's say about core network. Core network is also known as 5G core. Now, if we say about services-based architecture, then 5G core adopts a major agile and scalable architecture that is totally built upon the microservices. Microservices mean each and every component will be connected to each other using APIs, and they are very independent to each other. That means if when one feature goes down, another will not goes down. They are very loosely coupled with each other. Like this is also a small services, independent, or we can also virtualize network function or software components communicate through UPI. Now the thing is, what is the benefit of 5G core network? It also supports network slicing. The 5G core enables network slicing, which allows operators. Operators means like we can say ISPs, Airtel, Jio, or anyone who is providing 5G kind of services. It allows operators to create virtual networks that is called 5G slicing, network slicing. Network slicing that means from one physical network uh, we can create multiple virtual networks, and that virtual networks can be based on the different use cases. Like suppose if we want high broadband fast, high video streaming network, then we need to have high broadband kind of service. And if we need to have some kind of medical or healthcare kind of use case, then we need URLLC, which is also known as ultra reliable communication. Then here we can see here it is data network. The data network is a little bit confusing. It is in the shape of cloud. So what is data network? So data network is nothing but the services of internet. It can be like integrated. All this UE, GNODB, UPF can be. I will say everything. this data network can be connected with cloud also. 5G core can integrate it with cloud infrastructure for like on-demand scaling and deployment of network functions. So that scalability of network function is provided by data network. It will be connected to the internet or any cloud. Now let's talk about EPC. Yeah, anyway, in this diagram, EPC is not mentioned, but EPC is the concept which I think it need to be said. Evolve packet core. EPC means packet core, which was there in our 4G architecture. Like and 5G can interwork with the existing 4G network using EPC architecture. That means whatever architecture we used to have in 4G, that can be integrated with 5G also using EPC. Now let's talk about 5G system architecture, not service-based architecture. So this UE, when tries to communicate with G node B, this is the first step. During that time, what will happen is that PDU session is created, protocol data unit. Now the thing is, what is session? In networking field, session is very important. Session is like responsible for establishment of connections and maintenance of session and then authentication, and also it ensures security within to the connected devices. The function of session is like to establish and maintain and terminate the connection, and it also allows synchronization. It allows process to like add checksum that are considered uh, synchronization point in the data. This also sync like point to point, which help identify the error so that the data is resynced properly again if it's failed, and then it will resend and message does not cut permanently, and data loss is like avoided. This is the use of session. So in reference point architecture, we used to see that one line from here to here was there, which is also known as from UE to data network. One line was there, straight line. Okay, so such kind of line we used to see in our 5G reference point architecture. 5G reference point architecture is just for concept, and it has not been implemented in companies or operators. So such kind of pipe has been initiated from UE to data network. That is called PDU session, which is also known as protocol data unit. It is nothing but a session layer in from the TCP/IP in 5G, and it is just a series of connection from UE to GNB to the PUPF and then to the data network. That is the session network, which is responsible for any data loss and any kind of thing. So all the data traffic from the from is initiated from UE to data network is from PDU session. Now in 5G SB architecture, we can see that this line that has been developed uh, is called control plane function. The functions that are inside this box is called as control plane function, and the boxes which are outside like UE, GNB, UPF, and data network is called as UPF. Now, what is the difference between control plane and like user plane? Control plane is the like basic functionality which is provided by this architecture, and user plane is the thing uh, where the data flows will happen. Like data will flow from UE to GNB, GNB to UPF, then UPF to data network. Like this, the part which is inside this control plane is like it will facilitate the PDU session to happen for the UE. This control plane will facilitate the UE to happen the PDU session. And for every UE, when it wants to communicate with the data network or use data services, a PDU connection is created for that particular UE. That means, suppose this is a car and this is a mobile. So not only one PDU session will happen, for different devices, different like PDU sessions will created uh, based on the QoS, which is also known as quality of services, which has been provided from earlier. So the PDU session are just like unique to particular devices, and PDU session is just a series of connections from UE to GNB, GNB to UPS, and then data network. And inside this PDU session, one more line is there. If we say, like, suppose this more line is there from here to here, XT, this text. This is QoS line, and the above line is called PDU session. So each PDU session for each UE will have each QoS. And when the PDU session will created, then by default the default QoS quality of service, like, it will created. So this is all like PDU session and QoS. Now let's talk about our control plane functions. Let's start from AMF. The AMF. What is AMF? AMF is access and mobility function. So initial action to the network and mobility features is maintained by AMF, like registration and security. Then suppose when the mobile is active and the AMF knows its location and have information about it, then AMF have the registration area in this 5G, which learns what is the state of tracking area where the device is moving in a day. That thing it will track whether the mobile is active or not active, and from where it has been moving from one place to another plane. From this control plane function, this is that kind of thing is responsible by AMF. Like AMF also listen with the another network element. Like it will also listen to another network element which is like there in the UPL, the control plane function. Like it connect to the SMF function to initiate the PDF session. And also similarly, AMF has the communication with UDM and AUSF. That I will say what is UDM and AUSF. So it has to communicate with UDM and AUSF during the initial access, and that is because in order to ensure whether what kind of access it has to be given, because AMF is all about uh, accessibility and mobility functions. So it has to be taken care of all the security reasons, and it also like play very important role in authentication. Means the devices requested for the authentication is passed through AMF itself. That means suppose this smartphone is trying to access some services, data services. Then the first initial step is like it will go to AMF, and then AMF is responsible to see whether the requested device, which is this smartphone, is accessible or not. Like it is like uh, that is the original device or not, or for requesting whatever device, whatever data it has been requested, it will go to AMF, and then AMF will check whether it is like intended devices or not. And if it's intended device, then it will go forward and it will connect with GNB. Then the connection between UE and GNB will be established. So the connection between UE and GNB is established when the communication of UE to AMF will happen. It's not like directly UE and GNB will connect it. So that is the responsibility of AMF, which will let the UE and the GNB to connect. And also, like as the process of handover has been like explained previous session, so I will not cover it. What is the meaning of handover? Now let's talk about SMF after AMF. AMF is clear, right? So I will go to SMF. It is also known as session management function. I said about session in networking, what is session? So as we already discussed about the PDU session, so the creating and modification and removal of the PDO session is done by SMS. Okay, because it is session management function. So it have to maintain some session, and that session itself is this PDO session. Now, since SMF is like sitting in the control plane, it is SMF is inside the control plane, so it manages all the UPF and SMF UPF, and the SMS give command to the UPF to creation of PDF like PDU session. Now, if we say about how PDU like PDU session works, then PDU session like this session technically, then it will first initialize, then it will first negotiate, then the second is like resource allocation, and fourth one is data transfer. If we say about first step, that is initiation. What is like when we launch any application, suppose like web browsing or Instagram or Facebook or any games which is connected to the internet, then the UE initializes a PDU session to establish the process. Now, second is negotiation. The UE, like the user equipment, like such as car or mobile, will communicate with the 5G core network, which specifying the desired data network and the type of services is needed, whether it can be voice or it can be data or it can be video also. That is known as negotiation. Now the third one is resource allocation. Core networks negotiate with the various components like session management and function (SMF) and the UPF to allocate resources from the PDU session. This also like includes session assigning an IP address to your UE and then establishing QoS quality of services parameter if needed. Now the last one is data transfer. Once the PDU session is established, if the PDU session has been created from one device to another device, then your device can exchange the data packet with the designated data network through the created tunnel. This is the tunnel. This straight line is the tunnel. So each session handles data specific to application that initiated it. Suppose this card wants such kind of data which is not similar to what this smartphone has created. So this car will have different kind of services and this mobile will have different kind of services. This is how the PDU session will work. So this is all about SMF. Now let's talk about NRF, network is repository function. Network repository function. Whenever a new network element is rolled out, it registers itself in NRF. Suppose we want to create one more like functions here, then all the information about that network function is there in the NRF. It's a kind of database like MySQL and MongoDB, which have all the necessary information about this control plane or user plane functions information. So later when we try to query it, the NRF is the one which is responsible to distribute the information from one place to another place. So so when it registers, it means that the NRF has the IP addresses and domain name of the network element and other network elements which discover from NRF. So other network function needs to query to NRF in order to get addresses of the network elements. So that is the core concept of NRF, which it is a repository function where it will keep all the repository of IP address and DNS. Then let's talk about UPF now. It is also known as user plane function. It is the most important and critical role which plays, I mean, this UPF plays very critical role in handling user data traffic, and also it called as data plane. User plane and data plane are same components. So UPF is like present in 5G only. 4G it was some different name. So in 5G it is known as UPF. The main concept of UPF is to responsible for forwarding data packet between mobile devices such as user equipment and data network. So this is the use of UPF. The only use of UPF is to forward the requested data from UE to data network such as cloud or internet. So UPF need to be there. So suppose UE is trying to access a data packet. Suppose this suppose this UE is try to request a data packet, then what will happen is like this UE, such as this mobile or car, will decapsulate packet, which means removal of header information. It will remove all the header information, and it will then go to data packet, and then RAN comes into the picture. Now, once from RAN, it will go to the data network. Then in data network is the destination, and this is the source. From source to destination, suppose this source wanted a data service from this data network, then RAN will come into the picture. RAN will help to connect from UE to data network, and then in data network, before data network, in this point, as here decapsulation happened from mobile to G node B, then from UPF to data network, here encapsulation of packet will happen. That means adding necessary packet information. This this process is like known as packet forwarding, and it also like responsible for session management. The UPF interact with SMF within the 5G core to like establish, modify, and release PDU session or packet data unit session. Now I have said about QoS here, not QoS. Let's a little bit say about QoS again. It can be like UPF can also apply QoS policies. Policy is nothing but a rule or protocol. This UPF will apply quality of service to prioritize the data traffic based on the application need. Suppose this UE wants the gaming services from data network. So this UPF is responsible to provide this QoS policies based on which this UE will get such kind of services from this data network. Whether it can be voice call, it can be streaming of data, it can be URLLC, MVCC, whatever. Then the critical application like voice call or video streaming experience minimal delay. So QoS is the thing which will make whether this device will connected to this in how much delay, and for that UPF is responsible for that. Okay, so policy enforcement is also a thing which can be done by UPF. UPF can like enforce new network policies defined by the service provider, such as traffic filtering or charging based on the data usage. Now, that is the responsible of UPF. Suppose, yeah. So let's talk about UDM. This UDM. It acts as like a central repository for subscriber file and then related to user equipment UE connectivity. The if we say about the responsibility, then it is the subscriber and data management. Like it also store and manages all the essential data associated with subscribers, like subscriber profile, like IMSI number is there, then service plan, then permission, then QoS. Then it also UDM also is responsible for authentication of the data with like the subscription key will be provided. Now then registration of data will happen after authentication of data. Now, if we say about authentication and authorization, like this UDM connect interact with the like authentication server, which is also known as AUSF. This that's why it is in the same box. This UDM will communicate with AUSF for authentication to like facilitate the user authentication. It also provides subscription key and to subscription key to AUSF for verifying the UE identity and access rights, whether like access is there or not. So that is done by UDM. Now that is the when like network function are there. Now let's talk about. I will explain about this network function also. But before that, let's understand about CUPS architecture. Then after understanding of this CUP architecture, this NSSF, NEAF, then PCF will be easy to understand. Okay, so yeah, let's talk about CUPS. What is CUPS? In 4G, let's talk about 4G core to 5G core migration. Cups means like control and user plane separation. In 4G, it was not separated. In 5G, it has been separated. One is called control, and second one is called user. Like traditionally, if we say like in old days, in cellular network architecture like 4G, which is also known as LTE, that EPC was there, Evolve Packet Core function, which was responsible like for control plane tasks. Like what are the control plane tasks such as user authentication and then mobile management, mobility management, and then user plane tasks like such as data forwarding, data plane functions were combined within the single network element. In 5G cups, this functionality has been separated. So after separation, two names came. One is control plane, another one is user plane. So let's talk about control plane first. The control plane handle network control functions like user authentication, authorization, and then session management, mobility management. Like typically, it resides in a central location within 5G core network. This all this big box will be there in the data center, central, which is the central data center. That is also known as use control plane. It has been separated by cups. One is this, another one is this. Now let's talk about user plane. This plane like focuses on like this plane. This plane is like totally focuses on forwarding user data traffic like between UE, as I already have stated, UE and the data networks, which is also known as DN. This data network is also known as DN. Uh, and user plane function like UPF is deployed in distributed manner. That means we can have multiple UPF based on the use cases. Suppose there is one car, so that's why here one UPF is there. Suppose we have multiple cars, n number of cars. So the n number of cars we can have n number of UPS based on the use cases. So in this manner we can like have distributed manner, and it will also this UPF can. So as I have said that this core network will be installed in the data center, central data center, but this UPF is not about storing in the central data center. It can be situated in any edge network, like in towers, in nearby towers, or within any cloud or within any hardware near to the near to the network, which is also known as edge computing. This UPF like promotes edge computing. This is which is like closer to the network edge where the data are located. So suppose we have connected cars like connected cars of Tata Motors. So in each 5 kilometer distance, there can be a petrol pump kind of thing where UPF can be installed, and that UPF can be communicated with this car so that it should not go to the central data center to retrieve all the data and information. That is what I was saying. The user plane was there, and then one control plane is there, and this UPF can be installed in any closer to the devices, like whatever we have at petrol pumps in our like locations, like that for connected device and connected mobile phone. We can have like edge server, which is also known as UPF, and in that edge server we can install UPF, so that the processing of the data will be happen in the closer instead of this centralized location, so that it will have very reliable. And the concept of 5G is speed, so we can have so much of speed when we install UPF in the locations like cell tower and all. It will like it also UPF also like supports network function virtualizations. So in summary, if we say that then EPC, like which is like there as of cup is applied in EPC, which is like with separation of control and user plane. Then we are just segregating the PDN packet data network. Like previously in 4G, we used to have packet data network gateway into the control plane part and then user plane part. Similarly, the service gateway in 4G part SW and control plane part and the user plane part. And if we imagine that about the 4G, then what we had in our 4G architecture is like HSS and AAA. I don't know what is the function of that because I have not like studied about 4G network. Now we have AUSF and UDM in the 5G network, which is this AUSF. Okay, so this is 5G service-based architecture. Service-based architecture, each network function is like loosely coupled with each other and it follows microservices-based architecture. So each network function will have their another different kind of services. Like it has AMF, SMF. Then in user plane function we have UE, GNB, UPF, and data network. So all the basic like authentication, authorization, mobility management, handovering, storing of the necessary network, all network function information from the user plane, then all the like application kind of functions like AF, then we have this NEF, network exposure function, network repository function, has been covered in service-based architecture, and it has been provided by all the 3GPP compliance. 3GPP is nothing but SDO. So, like SDO means Standard Development Organization. They will make such kind of like 5G architecture, and they still have been doing this enhancement of this like new network function they will develop by 3GPP, and a few of the things which are not there in the 3GPP, they can also this 5G architecture can also like communicate with those untrusted like functionality. So this is the existing 5G architecture, and using this 5G architecture we can conclude different use cases based on different uh, demands.